Heading into the second half of our program this evening, Sabrina Elkassas is our next finalist, and she is joining us from the Massachusetts Institute of Technology and Woods Hole Oceanographic Institution, where she is a student connected to the Center for Dark Energy Biosphere Investigations, which is exploring microbial life in the deep biosphere, the rocks and sediment that make up over 70% of the Earth's surface. Welcome, Sabrina.
Imagine you are deep in the heart of Russia, trekking through these vast mountains, only to find this. A lake so toxic to life it seems almost extraterrestrial. This isn't sand that you see here along the shore. It's mineral deposits. Nothing should live here in these waters containing a huge amount of chemicals, like baking soda, which make it seemingly uninhabitable for life, right? Wrong. There are tiny, tiny microbes called archaea, which populate this lake. Now, they don't breathe air like you and me. They breathe hydrogen. They don't eat hamburgers and mac and cheese like you and me. They eat carbon dioxide. They exist outside the conditions considered normal for life, almost like aliens, right here on Earth. In my lab, I began simulating the conditions of this lake in this little vial. That's right, folks. In this vial, there are billions of microbes. Billions. But why bother? It's cool and all that I'm growing these, but why go through the trouble of growing them in the first place? I want to bring your attention to this picture here. I will give you a few seconds to come up with a guess of what you think it is. Okay, do you have your guess? Well, if I had to guess your guess, I would guess that you think it's the night sky or outer space, or in other words, really, really big. It is in fact not outer space. It is microbes under the microscope. Each one of these tiny blue dots is a microbe. However, I am growing these microbes to study outer space, so you weren't wrong at all if that was your guess. I am using these microbes to study what signs of life we should look for if we send a probe to explore the deep and ice-covered oceans of several moons in our solar system, which are shown here in comparison to Earth. The oceans on these moons are out of the range for sunlight to provide energy for life, and thus any organisms that live there would have to survive on chemical energy, just like the archaea do in the toxic lake here on Earth. I'm particularly interested in one of Saturn's moons, called Enceladus. Now, Enceladus has one of these cold and icy oceans, but it also has space geysers that gave us a window into detecting what its alien ocean contains. Turns out, that has all the right stuff to support this sort of life form. Hydrogen, its air, and carbon dioxide, its food. I hope that by studying these amazing microbes here on Earth, we can begin learning what sort of life could exist beyond. Thank you.